The B-29 was an American bomber that is remembered in history as having been the means of dropping 2 nuclear weapons on Hiroshima and Nagasaki. But technologically speaking, it was the first airplane in which structural units composed of ERGAL were used. Since that time, this material has been routinely used in the aeronautical, space, and nuclear fields. But not only. Because it is a material that combines great mechanical characteristics with extraordinary lightness, today it is commonly used in frames for bicycles, motorcycles, in high-performance cars, in motorcycle components, in the glass industry, in gearings. The more one has of it, the more one uses. But what is ERGAL really? In this case as well, we find ourselves confronted with a commercial name for several alloys of aluminum belonging to the 7000 series, also called aeronautical aluminum, in which the principal element allied with aluminum is zinc. These alloys are heat treatable and demonstrate the highest mechanical characteristics among the alloys of aluminum. In particular, 70-75 aluminum, zinc, magnesium is the most widely used. But in order to understand more about this product's true potentials, we must use our graphics. This is a graph of force versus deformation in a static traction experiment on steel. Now, I will draw for you the maximum result for ERGAL, which takes into account the differences among the various alloys and among the various heat treatments. The thing that immediately strikes you is the maximum mechanical resistance is comparable to that of a good construction grade steel, superior to 510 megapascal. And that if we set aside this difference in inclination of the straight line that derives from the difference of the elastic modulus, 70 gigapascal for ERGAL versus 210 gigapascal for steel, we can state that the mechanical behavior of ERGAL is comparable to that of steel, but with a weight that is 3 times less. Now let's talk about carbon. The value for the maximum resistance is around 2,900 megapascal, a value that is absolutely unreachable for the metals. And carbon achieves all this with half the weight of ERGAL. If we speak in terms of the ratio between resistance and weight, carbon performs 10 times better than ERGAL and 20 times better than steel. But what it is that makes the use of ERGAL preferable to that of carbon in certain applications? Well, first of all, this area that I am indicating shows the tenacity of ERGAL, or the energy the material is able to accumulate before reaching a breaking point, which is similar to that of steel and is far superior to that of carbon. This makes it the preferred choice for certain applications. A second positive aspect of ERGAL is the cost, which is midway between the cost of common steel and that of carbon. Thirdly, there is the ease with which it can be worked. It is a material that can be easily worked with tools. It can be soldered, it can be plastically deformed, and it can be extruded. Its inconvenient aspect is its tendency to corrode when proper precautions are not taken, and it is easily subject to tensile corrosion, which is to say, corrosion under constant mechanical load. See you all next time.